he points to autoimmune disease. We should check for lupus.
It's not lupus.
Do you want to explain to me why we're in the educational wing?
Because it's not the clinic. With any luck, there won't be anybody in this wing. At least this way we might be able to get a differential in peace.
Do you belong here?
Do you?
We work here sometimes.
Are you two doctors or are you teachers?
Janitors.
Who wears a suit coat over a t-shirt?
Where's a picnic table for a shirt?
Where do you really belong?
None of your business.
Cool. I love puzzles. So, either one of your parents teaches here, and we've never seen you before, or one of your parents is a patient here being treated. I imagine that's probably what you're looking up on the laptop.
What are you looking up?
What is HIV?
Easy. One of his parents might be an HIV patient here. What do you want to know?
Why can't antibiotics cure HIV?
HIV is a viral infection. Let me explain. HIV is a virus. It's different from bacteria. It has a protein coat called a capsule, and inside is genetic material. The difference between viruses and other organisms is they lack cellular machinery. They do, however, want to proliferate and replicate just like all other organisms.
Replicate and proliferate?
Organisms are egomaniacal. They're sort of egotistical. They just want to copy themselves and send out their information all over the planet. If you wanted to make copies of yourself, what would you do? Well, you could either use a copy of your own, or if you didn't have one, you'd use someone else's.
Replication.
Proliferation.
So replication is making the copies and proliferation is spreading the copies?
That's correct. Most organisms use DNA as the genetic material, including most viruses. However, HIV uses RNA. HIV is a retrovirus, so it converts its RNA to DNA to be used in the host cell.
The HIV virus uses an enzyme called reverse transcriptase to change its RNA into DNA. Then, picture this little pink ribbon as being the host cell's DNA. Picture this yellow ribbon being the newly synthesized viral DNA. What's going to happen is it's going to splice its own viral DNA into the host cell's DNA so that it can use the host cell cellular machinery to replicate itself.
How does the genetic material get into the cell?
Excellent question. Our body has an immune system. It acts as an army. In each army, there's a general. In this case, our general is the helper T lymphocytes. The helper T cell has a receptor on its surface called the CD4+. The HIV viral particle binds to the CD4+ receptor and injects its genetic material into the cell.
It injects it like a shot, replicates it, then what happens?
Once the HIV virus replicates itself, one of two things can happen. One, the virus can basically lay dormant in a host cell and just keep replicating itself. In this stage, a few viral particles could butt off the membrane and cause further infection, but for the most part, you won't see any symptoms. It's called the lysogenic cycle. A more violent cycle that could take place is called the lytic cycle. Picture this balloon as one of your body's cells infected with HIV.
First ribbons, now balloons. Where are you getting all this stuff?
Stolen from the children's ward. What do you care? If you look closely inside this balloon, you'll see a bunch of red confetti. If this balloon is a body cell, all that red confetti is newly made viral particles. What happens in a lytic cycle is once all these particles have been synthesized, the cell's basically going to lyse or explode.
Come on, now I'm covered in confetti.
And therefore now infected with HIV.
How did you figure it out?
I was referring to you as a cell being infected by the lytic cycle, not you personally, but it's pretty clear that it's not one of his parents who are here being treated for HIV. It's him.